피자 음료수는 편하게 드시면서 화면에 놨죠.
So is this working? Yeah, it's working. Yeah, very happy to be here. Thanks for organizing this. Thanks to Ken, thanks to Sunny. Where is she? There. You documented this. This is good. Pixar, it didn't happen. Yeah, I'm going to talk today about how open source and ClickHouse are changing and redefining the data warehouse landscape. Well, so first of all, who of you knows about ClickHouse?
클릭하우스에 대해서 아시는 분?
Okay. So ClickHouse is a database, and ClickHouse is used for four use cases, basically for four kinds of use cases. We have real-time analytics, which is where it plays in a league with Druid, Pinot, Starox, a few others. Data warehousing, where we are trying to a little bit to each the lunch of Snowflake, BigQuery, and those. Number 3 is observability, where we have our own solution. Maybe we'll have a little bit time later to talk about that as well. Number 4 is AI/ML, and we've got some quite interesting stuff coming there. But today I'm talking about data warehousing. My name is Hellmar. I'm from Germany, so apologies that I have to do this in English.
I'll make it summarize in per
Yeah, exactly. Here is my translator, which is awesome. I've been working with Ken for how many years?
Almost two, more than two.
More than 2 years. I think more than 2 years. Yeah, we met at Imply, obviously, and yeah, when it came out that I went, I was on vacation here, but.
휴가지에 찾아주는.
We were talking like should we organize a meetup, and yeah, well, Ken and Sunny made it happen. So thank you very much for that. I'm obviously a bit older, so yeah, I've done analytics for 25 years. In the beginning with Oracle, then at some time with Netezza. I think that was probably when you did Vertica. And yeah, then there was Hadoop at some time, and then there was Imply, and now there's ClickHouse.
There was Confluent too.
And there was Confluent too, yeah, right, I also worked at Confluent. And
폴트녹스, 컴플루언트, 임플라이, 기타 등등 그 전에는 이제 DW 쪽 뭐 이런 다양한 경험을 갖고 계시고요. Yeah. When did you start your blog?
when did I start? I started my blog, I think in 2020 at Imply.
COVID.
Yes. Because at some time I thought, first of all, I like to be outgoing and explaining. There were also at that time there were some gaps in the documentation where I felt like, yeah, maybe somebody needs to figure out how this works and then write it down so the next person has it easier. Also, of course, it's a bit of a personal brand. So I used to blog about Druid at Imply for quite a while, and now I'm occasionally blogging about ClickHouse, but I've got so much work to do that I hardly get around to it. Yeah, so that's me. Now, I was already talking about it. Oracle, and then Netezza and Hadoop and all this. So data warehousing has been, this is our product lady, and she says, we owe a lot to the cloud data warehouses. And yeah, that was like 10 or even like 5-6 years ago, was basically the thing, to have Snowflake or BigQuery as the cloud data warehouse. And how did that come to be? Data warehousing it happened like 30 years ago. People started building data warehouses because, yeah, we had databases. And I still remember in the 80s, it was cool to have a database because you had a relational database. You could set all kinds of entities into a relationship against each other. But you had to normalize your schema because if you wanted to insert or update a record in your database, it was very important to have to change things only at one place. So you started building third normal form and all that. And it turns out that if you build a database in that way in order to get data in a reliable, transactional way, then it would be very hard to get data out again, because you would then have to get your data from a lot of tables, you would have to join these data, and that would take a long time, it would take a lot of resources, and if you did that on your production database while you were trying to insert and change your data, it would usually not be a good idea. So people started building another kind of database, analytical databases. The business side of that was defined by Inmon, and the technical side by Kimball. We got the star schema, and people started building this kind of stuff on premise. Yeah, here we've got companies like Oracle, Teradata, IBM. Oh, I also worked at IBM one time, by the way. Yeah, and Hadoop, although Hadoop was a bit later, 30 years ago we didn't have Hadoop yet. Hadoop came then maybe about, like when was Hadoop? 20 years ago? 15 years ago, 20 years ago. And Hadoop came from the need of processing ever larger amounts of data. And so then we started building architectures that had a close coupling of compute and storage in a distributed way, very complicated to operate and to manage. And then at some time, that was about 10 years ago, the Snowflakes and BigQuery came to the market with the idea to democratize analytics. So they got all the scaling, they got a SQL interface, which meant you could relatively easily, as an analyst, access those data, and that made for democratization of data. More people could access the data, integration got easier. So all in all, life was good, right? Or, yeah, well, until it wasn't. Because on the other hand, these cloud data warehouses worked very much in batch mode. So what if you wanted to have something like this, a live dashboard for something? So in this case, this is one of our demo apps, which maybe I'll later have time to show very quickly. This is about Python package downloads and how popular each package was and is right now, how it is downloaded, what kind of package format people use to install and all that. And you want to update these data in near real time. Snowflake or BigQuery is not good for that. Here we have a short video about that. So this is how you want to interact with your application. You want to have a snappy, quickly updating dashboard where you can interactively select, and basically like imply pivot, which is what people really love about imply, right?
Yeah, pivot is amazing.
Pivot is amazing. I really love it, yeah. And it's one of the things that I miss about imply. So that is what you don't really get with the cloud data warehouse. With the cloud data warehouse, be it Snowflake, be it BigQuery, be it Redshift for that matter, you have vendor login. You don't really get this kind of real-time interactive response, or if you want to get speed out of it, then it gets expensive very quickly. And this is the fundamental limitation. That is why I hear in my conversations with customers and prospects, ever and ever again, I hear, yeah, this is so expensive. So what happened was people started to put open source alternatives into the fast path, like Druid, like ClickHouse, like the others. And on the other hand, what also happened was that for the slower and bigger amount of data analytics, people started to adopt data lake formats. And data lake formats, I mean, they originate back in the day. I always say it's the return of the son of Hive. And that's how it all came to be, although nowadays, of course, these formats are more flexible and they can do a lot more. So these are the two families of product that we got. We got open source analytical databases like ClickHouse and Druid. Somebody also put Elastic here, although I would argue about that. Elastic is another use case. On the other hand, you've got open data lake formats, Iceberg, Delta Lake, Hudi, and a few others. And now my talk is going to be about how all this comes together. So, what are data lakes? This is well, this is probably, each of you knows this kind of diagram. This is like, you know, the zoo of an analytical data architecture where you put all kinds of stuff. There's some Hadoop in there. There's ETL or ELT where you have got Spark and DBT and God know what else. Talent, Informatica, Fivetran. You've got various data warehouse technologies, and then you've got all your data consumers at the end. And of course, you've also got the observability layer that monitors the entire thing. Not everybody uses all of those, but you've got usually some complexity in here. Now, what if you want to have all these data repositories, you want to kind of unify it? So you want to have one data format that is accessible by everyone. Then you end up with a data lake. And this is what we all tried to build with Hadoop. But yeah, then we had Hadoop, we had Hive. So the idea is you've got, at the lowest layer, you've got data in an open source, open storage format in cloud storage. So the file format at this level would be something like Parquet. It could also be CSV, although Parquet is kind of a quasi-standard now. On top of that, you've got a catalog that ties it all together. On top of that, you can put any query engine of your choice. You could run Spark on it, you could run Dremio on it, you could run Snowflake on it, but you can also run ClickHouse on it. And this is where we are all going today. And I think the main thing in the middle nowadays that everybody prefers seems to be Iceberg. I'll come to that in a moment. So these are the things. You've got a table format, which is how to view a collection of data files and put a structure on it. You've got table management, you've got management of the history of the table, management of transactional behavior like updates and deletes, and then you've got a catalog that ties it all together. Here are some of the open lake data lake formats, and I think this is a bit like the videotape wars of the 1980s, where at some point then VHS emerged as the winner, and I think the winner nowadays of all these formats is pretty much Iceberg.
Yes.
Do you agree?
Yeah, Databricks did some foolish things. 원래 제가 굳이 번역이 필요 없다고 생각하는 부분들은 안 하고 있습니다. 네. 네. 대부분 현재 데이터베이스를 사용하시지 않는 경우들은 대부분 다 아이스버그 쪽으로 가고 있겠죠. 네. 데이터베이스가 데이터 레이크를 오픈소스화만 좀만 빨리 했어도 이런 일이 일어나지 않았을 텐데 예. 아이스버그로 대부분 흘러가고 있다. 여기까지. 예.
Yeah. So that was the short excursion about data lakes. Now, what are analytical databases? Let's ask ChatGPT and let's forget about this. So, analytical databases are, or should I go back to it? High-speed querying, scalability, distributed architecture, cost-effective, use case data warehouse, business intelligence, reporting, real-time analytics. Best and fastest example, and this was what was spit out by ChatGPT, is ClickHouse.
What was the prompt?
Somebody from our marketing did the prompt, okay. Yeah. Well, ClickHouse is, but however, this is indeed immensely popular. And I do remember in the Imply days, I did a graph like this, and it really goes like this. So at some point, I think we are now at 40K or even more. And the point is that there is a limit at 50K. I think you kind of pull more out of the API of GitHub, or you run into a limitation. Because to get these data is actually quite a hassle. If you now I was comparing, I was cross-referencing them, and that was quite an interesting thing. But ClickHouse is really growing, and you can see here that this has been around. ClickHouse has been open source at that time for about 7 years. I think now it's a bit more. But ClickHouse has actually been around for a longer time. ClickHouse is an open source, column-oriented, distributed OLAP database. So this is, in short, what we are. Open source means, oh yeah, so it has been open source for 9 years now, yeah. So the graph was not quite up to date. It has been around since 2009. ClickHouse originally was developed in the context of Yandex in Russia as a clickstream data warehouse, because, well, obviously Yandex as a search engine and ad software has a lot of clickstream data, and clickstream analytics was always one of the most interesting things. I've personally done clickstream analytics for like since 25 years. Back then it was already a challenge because, first of all, because of the sheer amount of data, then because you need to sessionize your data, you want to count unique visitors, you want to do campaign attribution, so quite some complex use cases. And back in 2000, when I started with that, we had only relational databases to do all this stuff. And then more and more companies actually ran into that problem. They said, how can I analyze these data quickly? That is how Druid was born. That is also how ClickHouse was born. So ClickHouse, out of the context at Yandex, developed since 2009, open sourced 2016 under an Apache license. 2020, I think, the company ClickHouse was founded by a team of American investors. The core developer team, well, they bought out the intellectual property. The core developer team was relocated mostly to Western Europe. And nowadays, the company ClickHouse, which I'm also working for, I'm proud of that, is headquartered, legally headquartered in the US, but we have only one office. We are otherwise fully remote. We have one office that is in Amsterdam in the Netherlands.
러시아의 이제 얀덱스라고 하는 그 당시 이제 광고 분석을 제일 많이 하던 회사에서 그 클릭스트림 하우스라는 프로젝트로 시작이 됐었고요. 뭐 이거는 카프카가 링크드인에서 시작하거나 뭐 드루이드가 그 메타마켓이라고 하는 회사에서 시작된 거하고 비슷하게 그렇게 이제 시작이 됐었고, 그냥 우스갯소리로 이제 그 러시아 대 탈주 교육이라고 표현을 하지만 그 프로젝트가 이제 잘 인큐베이팅이 돼서 그 이제 IP를 그 미국 투자자들이 이걸 샀고, 그때 이제 그 핵심 러시아 개발자들이 유럽으로 이주하면서 이제 법적 주소지는 이제 미국 회사로 되어 있기는 하지만 메인한 오피스는 암스테르담에 있는 회사로 이제 2020년에 클릭하우스라는 회사가 이제 공식적으로 이제 설립이 됐습니다.
So that was the open source part. Then we've got column oriented, and I mean, you all know about column oriented databases. So you have the data represented in a column format. In ClickHouse, give or take with a few asterisks, each column in a so-called data part is represented by its own file. And because those data in one column file are all of a similar type and similar structure, data compresses very well in ClickHouse. ClickHouse also has another very interesting philosophy, and maybe I should just kind of compare that to Druid. In Druid, we've got segments. Segments are give or take 500 MB in size, and they are sorted by time, mostly. Again, with a few asterisks. But that is basically the story. In ClickHouse, this is a bit different. We have, as a core, at the core there are table engines. Table engines determine how data is stored. And data is stored in so-called parts. Parts don't have a fixed size, and they are always merged in the background into bigger parts, up to a limit of about 150 GB. Within the parts, data is chopped up into granules. Each granule usually corresponds to 8,192 rows, 8K rows. And within each part, data is sorted by a key of your choice. At the core of the table definition in ClickHouse is the definition of the sorting key. It could be the time, but more often than not, it is not. It should be the fields that you use most frequently for selecting and filtering upon. Because with the sorting key comes a sparse index, which has one entry per granule. So per 8,192 rows, it has an index entry of the value of that key that corresponds to the beginning of the granule. So that if you select by that key, you know you can prune very aggressively. You would read only very, very little amount of data. And that is at the core of how ClickHouse is fast. So it works a little bit like phone books of old. If you remember printed phone books, or still, you probably don't have them anymore. We haven't had them for a while. And on top of each page of the phone book, there's the first name that is on the page is printed in bold, so that you can look up things quickly. This is how our sparse indexes work.
클릭하우스는 뭐 드루이드 이제 세그먼트라는 파일이 있지만 클릭하우스는 이제 파츠라고 해가지고 그래서 이제 그 작은 파일들이 많이 들어오면 이제 약간 뭐 이슈가 생기는 경우들도 있지만 결국에는 테이블 데피니션이 있는 그 로지컬 뷰가 있고 거기에 이제 파츠라고 하는 게 정리가 되고 거기에 이제 이 파츠의 개별적인 물리적인 파일 사이즈는 제약이 없으면서 이제 계속 뒤에서 이제 그 백그라운드에서 머지하는 게 이제 클릭하우스의 가장 큰 특징이고요. 그 다음에 이 파츠 안에는 이제 8K 로우로 구성된 이제 세분화된 파일들이 있으면서 그 각각 세분화된 파일들은 그 소트 키를 가지고서 그러니까 드루이드 같은 경우에 이제 타임 언더바 타임 컬럼으로 이제 소팅되는 게 기본 골자라 그러면은 클릭하우스는 그거에 좀 제약 없이 소트 키에 따라 가지고서 파츠 밑에 파일 레벨에서 개별적인 인덱스 아까 저희 영어 사전이나 옛날에 이제 전화번호부 보면 가나다 순 위에서 이제 이 페이지에 가장 첫 번째 있는 사람하고 맨 끝에 있는 사람 갖고 이 헤더 값을 보고 이제 소위 말해서 프루닝 읽을지 말지에 대한 여부를 정하듯이 그런 식으로 이 파일 레벨에서 그 시작값 소트가 되어 있는 키로 이제 쿼리를 했었을 때에는 실제 읽어야 되는 데이터를 최소화할 수 있는 기법들을 이제 많이 넣어놨다. 그게 이제 클릭하우스 핵심이다라고 이야기를 합니다.
So then distributed. Well, again, it's not new to any of you. ClickHouse is in the open source version. It has a replicated and sharded architecture. In the cloud version, it is virtual replication. You can just scale out indefinitely. If you need more servers, you just add more servers. They all access the same storage. We have in the cloud version, we have a separation of compute and storage. It's a multi-master architecture, so any node can execute any query, either as a single node query or fork out as a distributed query. And you can even set up a cross-region distributed architecture. And it's an OLAP database, so it is made for analytical use cases, mostly immutable data, aggregations, visualizations, mostly immutable. This is an interesting thing because, like most other data warehouse or analytical databases, ClickHouse was built as an append-only data store. However, we started at some point doing things with the table engines where you could model updates to individual records as inserts. So we have not only the merge tree that I just mentioned, but we have got also a thing like that is called the replacing merge tree, which can process updates by using background merges. And brand new, fresh from the press, we have true fast updates now. Just came out in the last release call, and it will come to the cloud, I think, next month. So we have fast updates now, transactional updates, which is, I think, a game changer.
그 전에 클릭하우스 사용하시는 분들 이야기를 들었을 때는, 그러니까 그 전에는 클릭하우스가 뭐 드루이드에서도 뭐 리플레이스를 뭐 리인덱스라는 방식으로 이렇게 수동으로 구현을 해야 됐지만, 클릭하우스는 예를 들어서 업서트나 이런 것들이 발생하게 되면은 테이블 엔진이 뒤에서 이제 리플레이싱 소트를 통해 가지고 아까 그 뒤에서 머지가 발생하듯이 그 백그라운드에서 변경 작업이 생긴 부분들을 바꿔주는 뒤에서 백그라운드에서 바꿔주는 식으로 이제 그 전까지는 진행을 했었는데 저번 그 릴리즈에 뭐 한동안 이렇게 프레스나 링크드인 같은 데에서 이렇게 좀 크게 많이 공유가 됐었는데 이번 그 신규 릴리즈에 이제 리얼타임 업데이트가 나왔고요. 그래서 이제 실제로 업데이트가 되는 DML을 지원하기 시작하는 형태로 오픈소스 버전의 릴리즈가 됐고 이제 그 사스 버전인 클릭하우스 클라우드에는 아마 다음 릴리즈에 들어간다고 합니다. One question: Does the ClickHouse mechanism provides the table level lock, or what is the level of the locking for the updates? Is it likely to be the table level? I guess.
I suppose. No, it's actually, I think it has a free concurrency. So it's more like a snapshot isolation. Because what we do is, whenever you insert data into ClickHouse, you create a new part, which is why you can have as many concurrent inserts as you have. We don't have a primary key. Well, we have a thing that we call the primary key, but it's actually the order key. So you can have concurrent inserts. Now, what happens with the updates is we create a patch part. And the question is not, we don't actually overwrite data. Yeah, so we create the patch part, and the question is, if you do a query at the same time that the update is active, then there is, of course, the question, does the query already see the updated part or does it not? What the update does is it creates a patch part, and as soon as the patch part is visible, then the next query will pick up the patch part and it will know how to apply it on top of the main parts. There's a whole blog about it, which was just released 1 or 2 weeks ago, which explains the mechanism in great detail. Because, of course, as background merges happen, then the patch parts are incorporated into the main part. And there's also there are like 2 ways of referencing the main part in the patch part. One which is just referring to row numbers, but then of course what could happen is that before the patch part gets merged, the underlying parts could already be subject to a merge process while the update is happening. For that there's another kind of reference pointers, so that the patch is always also during the merge applied to the right point in the data.
기존의 뭐 MySQL이나 아니면은 그런 그 오라클 같은 뭐 리두 언두 해가지고 이렇게 실제 레코드를 덮어 쓰는 방식이 아니라 원래 이제 얘기했던 것처럼 데이터가 쭉 들어오면 이제 쪼개진 상태로 이제 파츠들을 만들고 그거를 이제 백그라운드에서 머지해서 만드는 구조였다 그러면은 거기에 이제 약간 저널처럼 그 변경 부분에 대해서는 패치를 이제 추가로 만드는 거죠. 이 파트 안에서 특정 로우는 업데이트가 된 거니까 이제 요거까지 덮어 써야 반영이 된다 하는 식으로 하고 이제 뒤에서 머지가 돌 때 이것까지 다 반영해서 많은 식으로 이제 동작한다라는 설명을 했고, 다만 이제 그러다 보니까 이게 지금 업데이트가 발생하고 있었을 때 이제 커밋이라는 커맨드가 있다 그러면 저희 체크 포인트 기준으로 봤었을 때 그때 이제 쿼리가 들어온다 그러면은 사실 이런 것들이 이제 체크 포인트 관리나 이런 카탈로그 관리가 어떻게 되느냐에 따라서 얼마나 이제 컨커런시를 잘 핸들링할 수 있는지가 나올 것 같은데 그 부분은 그 2주 전에 공개된 그 블로그에 아주 상세하게 잘 나와 있다라고 합니다. 네.
So these are some examples of customers where we have petabytes of data, trillions of internet requests. One that is not yet on that list is Tesla, which back then we couldn't reference, but they spoke publicly for us. So Tesla is using ClickHouse for observability on their whole architecture, on their whole IT infrastructure. Another of our customers is Anthropic, company we upload. And this is a big use case, is monitoring or observing LLMs and how they have been prompted, what kind of answers they gave in order to be able to hold them accountable.
테슬라랑 엔트로픽 AI는 여기 실려있지 않고 테슬라는 전체적인 시스템을 관리하는 그 관제의 근간 DB에 그 다음에 엔트로픽 AI는 그 LLM의 출력을 저장하고 분석하는 데 활용되고 있다고 합니다.
So, why ClickHouse? If you want to build an interactive data-driven applications and you need high concurrency, that is another thing where data warehouses are not so good at. But I don't know what your experience. You used to work with Logica. When I worked with NetEaser, I know that the NetEaser was always super fast, but when you try to run many queries at the same time, it would quickly give up.
Vertica was better than NetEaser.
Okay. Yeah.
But usually like from the data warehouse BI perspective, usually maximum concurrency kind of goes limits by 20 or maximum 40.
Yeah, and of course we can handle a lot more. So, the question was, and we ran this as a benchmark, the question was, how do you build an interactive application? We saw this as a video earlier on top of Python package downloads, and we compared ClickHouse versus Snowflake, and these are the numbers. 3 to 5 times less compute usage, 38 times more effective compression, although we see another number later, and all that is at double the speed. Here are some examples of the benchmark results. See, ClickHouse is generally faster. Data compression. In Snowflake, you have to get the right kind of clustering key in order to get good compression. So here we have like a 6 times compression, but with proper, so here in ClickHouse, you get, if you use the same kind of key, you get 8 times compression. With the optimized key for ClickHouse, which is this one here, you get more than 9 times compression. And then you can, in ClickHouse, you can even manually tune the codec for each column. You can choose the compression algorithm, then you get even a little bit more out of it. So there's a lot of things that have been very, very carefully optimized. And if you happen to listen into one of our monthly release calls where our CTO speaks, he likes to elaborate on these little things.
컬럼별로 이제 다른 코딩 압축을 통해서 뭐 RL이라든지 해가지고서 뭐 예를 들어서 뭐 학번 같은 경우에는 앞이 갖고 뒤에서 또 올라간다 그러면 이거를 잡고 그냥 델타 값만 저장한다라든지 뭐 이런 것들이 이제 그 컬럼마다 이 소위 말해서 그 결국에는 압축이라고 하는 게 중복을 제거하거나 아니면 레퍼런싱 할 수 있는 값을 최소화하는 거죠. 그러니까 학번이 8자리인데 어차피 특정 학번은 다 똑같고 그다음부터 1, 2, 3, 4, 5, 6, 7, 8이면 이제 요걸 빼놓고 그냥 다 뺀다라고 생각하면 이거 값이 하나 있고 그다음에 1, 2, 3, 4, 5, 6, 7, 8 쭉 있는 거니까 그런 식의 이제 컬럼별의 컬럼별의 이제 인코딩을 하는 알고리즘들을 설정해서 튜닝을 하면은 훨씬 더 이제 그 소위 말해서 파일을 효율적으로 그 축약해서 쓸 수 있다. 이런 얘기들을 좀 하고 싶었던 것 같습니다.
Yeah, finally the cost comparison. So we've compared the Snowflake cost for the same setup with ClickHouse. I mean, the fair comparison is apparently this one here, Snowflake Enterprise, 2x large compared to ClickHouse, and even with that, you have a 4.7 times cost saving with ClickHouse, and this is something that we see very, very often. So I've talked about data lakes, I've talked about analytical databases, how does it all play together? And well, the question is, can you just do with one of them? Can you just do with a data lake? Because it promises to do everything, but really, is it fast enough? How much longer does it take you to write data to the data lake? How much faster does it take you to query the data lake? And the answer is, this is the ClickHouse graph. And you can scale almost indefinitely. You don't get that with your data lake technology. So as this curve here falls, you see the x-axis is the number of ClickHouse servers. And that's what I just mentioned. ClickHouse is built for really fast concurrent inserts. People are literally processing billions of events per second with ClickHouse. And the way this works is by making all these inserts completely independent and without any locks or anything. No locks, no breaks. Same for streaming ingestion. Real-time analytical databases are optimized for streaming ingestion. This is again something which I don't have to tell you, right? And we have streaming integration built in ClickHouse as well. We've got a specialized Kafka table engine which allows you to set up your Kafka ingestion with plain SQL. We also have ClickPipes, which is native to our ClickHouse Cloud product, where you get to configure your Kafka ingestion pipeline just with a few clicks.
카프카에서 입수를 select 문으로 설정해서 할 수 있는 커넥터를 갖고 있고, 그 다음에 이제 클릭파이프라고, 약간 스노우플레이크는 스노우파이프가 있고 이런 그 클릭하우스 클라우드에는 그런 뭐 클라우드 전용 클라우드 전용 커넥터들을 이제 파이프를 붙여가지고서 이렇게 이야기를 하고 있는데 그런 파이프들이나 이런 것들을 통해 가지고서 그 클릭하우스 오픈 소스도 기본적으로 드루이드나 다른 여타 리얼타임 엔진을 표방하는 것처럼 뭐 스케일러블한 인서트 작업이나 아니면 카프카로부터 실시간으로 들어온 데이터에 대해서 유연하게 확장할 수 있고 그 확장하는 만큼 성능을 더 개선할 수 있는 그 내재화된 기능들을 다 가지고 있습니다.
So why do you want to combine data lakes with analytical databases? On the one hand, it's the reading speed. On the other hand, and the writing speed. On the other hand, it's the reading speed. And this is our popular. It's another. By the way, this is public data. You can access this website, the ClickBench website. There's a link here behind it, where we continuously run, our community runs benchmarks on various databases, various hardware configurations, in order to compare which database is fastest. It is not always ClickHouse, but it's quite often ClickHouse. And one thing that we found out is that reads against data lakes are 2 to 14 times slower than reads against ClickHouse. And why is that? Well, it's mostly because each read in a data lake format, and you remember how we were looking at this table format where you go to the catalog, then you have to go to the table metadata, then you have to go to the manifest level, and then only after like 3 or 4 levels of interaction, you access the actual data files. Each of these accesses gives you an additional 50 to 100 milliseconds delay on S3, which is why you have to mitigate this with aggressive caching. But then again, well, we know there are 2 hard problems in IT, right? And one of them is cache invalidation.
그러니까 데이터 레이크에 있는 파케나 아이스버그에 있는 파일에다가 이제 쿼리를 하려고 그러면 뭐 기본적으로 이제 IO도 있겠지만 아까 얘기한 것처럼 테이블 데피니션이 있고 그 다음에 거기에 이제 매니페스트 파일이나 그 밑에 이제 구성되어 있는 구성 정보나 이런 것들이 있다 보니까 그리고 그게 보통 이제 파케 같은 거나 아이스버그에는 이 파일 헤더에 이제 같이 붙어 있다 보니까 이 파일을 읽고 그 다음에 어떤 식으로 데이터를 탐색해 나가지를 의사결정하는 데서 이미 앞단에서 생기는 레이턴시가 길어지다 보니 기본적으로 느려질 수밖에 없는 이런 부분들을 갖고 있고 이 문제를 해결하기 위해서 뭐 델타 레이크 테이블과 같이 뭐 기타 등 이제 캐싱이라는 메커니즘을 통해 가지고서 이 부분을 해소할 수 있는 방법들을 갖고 있지만 캐싱이라고 하는 거는 이제 또 캐시에 대한 관리나 그 다음에 캐시에 대한 어떤 변경 부분이 생겼을 때에 대한 이 싱크를 어떻게 할 것인가 하는 여러 가지 이제 컴퓨터 공학이 근본적으로 갖고 있는 문제들이 같이 잔재되어 있죠.
So, how do you combine these things? Well, there are 2 ways, essentially. Number one is you use the data lake and the real-time analytical database in parallel. It's pretty much what we used to know as the Lambda architecture. You have fast insertion and fast queries in the fast path, and then you have another path for your historical data that goes into the data lake in, for instance, an iceberg format. The other way is you ingest all your data, and this is also quite common, and it's sometimes the less painful way to migrate. You ingest all your data into one repository, which is your data lake, and you can use your real-time analytical database as a speed layer. You can run federated queries directly against the data lake. You can ingest certain data from the data lake in order to have them in the native format of the analytical database for really fast queries. And you can even use the compute engine of your real-time analytical database in order to store data back into the data lake in aggregated format.
뭐 처음은 이제 병행 입수를 그러니까 데이터가 있었을 때 레이크 쪽으로 하나, 그 다음에 클릭하우스 같은 그 리얼타임 데이터베이스로 양쪽으로 이제 데이터를 적재하는 방법이 하나 있을 것이고, 물론 이제 별로 선호되는 방법은 아니죠. 그 다음에 이제 데이터 레이크로 적재를 한 다음에 필요하다 그러면은 SLA가 높거나 아니면은 좀 더 중요하게 봐야 되는 것들은 이제 적재를 하거나 아니면은 뭐 그런 쿼리 페더레이션 같은 것들을 활용해 가지고서 에도 쿼리를 이제 던져가지고 활용하는 방법들이 있을 겁니다.
So, this is how you integrate things. Some examples, and but first of all, how do you deploy ClickHouse? Now talking about ClickHouse as the analytical database. These are the ways to deploy ClickHouse open source. And ClickHouse open source can be deployed basically in any size. You can deploy it as a distributed system with many servers and accesses with the client. You can run it locally on your laptop. I do that for experiments quite often. And there's even an in-process ClickHouse version, which you can download as a Python package. You can run it inside your Python script. Much like SQLite, but for analytical purposes.
클릭하우스 DB로 배포하는 거, 그 다음에 이제 노트북에서 테스트용을 배포하는 거, 그 다음에 SQLite처럼 파이썬 프로세스 안에서 이제 뭐 패키지용으로 그 활용하는 방법, CHDB가 이제 그런 용도로 이제 이런 식으로 이제 오픈소스 클릭하우스는 활용할 수 있도록 구성이 되어 있습니다.
And then there's of course, so this is how easy it is to install. So what you do is you just pipe actually you just say is curl www.clickhouse.com, pipe this into your shell, and there you go. Now, the other thing, which is even easier, is ClickHouse Cloud. And in ClickHouse Cloud, you can just define your database to have a network connection. So you see, you define your service, you say, this is my cloud provider, my region, and then you can choose the configuration, and then within a couple of moments, you've got your database ready. Download your access credentials, and you're ready to run queries, you're ready to insert data. So this is really the 2-minute start. It's also available as a link on our website. Just go to the starting page. You get ClickHouse Cloud account for free with 30 days free trial and 300 credits. So it's really fun.
국내에 아직 미장이 없지만 클릭하우스 클라우드는 물어봤는데 이미 국내에 있는데 사실 국내에 이제 해외 서비스를 디플로이하신 곳에서는 쓰고 계신 곳이 벌써 있다고 하더라고요. 뭐 그렇습니다. 빠르게 쓸 수 있습니다.
How to query data in ClickHouse? You can use ClickHouse as a query federation engine, although that is not the main usage of it, but you can do it. So you can access files that live in cloud storage in a variety of formats. There are dozens of different formats that are supported. We have by now first-class support for most of the data lake catalog formats. So also I think new, fresh from the press, we can write iceberg tables now, but we have been able to read iceberg tables for a while, same for Delta Lake, for Hudi, and for a few others. We have also AWS Glue directly and a few others. If you want to be really fast, then of course you ingest your data into ClickHouse, store those data in the native format, and query it directly. In ClickHouse Cloud, you have a SQL console, and you've got a SQL query copilot, so you can actually run your. You can enter your query in natural language, and it will generate the SQL for you. Also new after these, I made these slides, we released the ability, if you have your ClickHouse client on your laptop, you can also enter natural language stuff there. Although then you will have to have a either an OpenAI or an Anthropic API key in order to use it.
그래서 오픈소스 쪽으로는 예전에는 우리 DB 안에 우리 DB 포맷으로 데이터를 넣으세요. 그리고 추가적으로 파켓, 나가 아이스버그도 조회할 수 있어요가 그 전에 나온 기술들이 포지셔닝 방식이었다 그러면 요즘 나오는 기술들은 어쩔 수 없이 저희 아이스버그 잘 읽어요. 아이스버그에 쓰실 수도 있어요. 근데 조금 더 빠른 걸 원하시면은 적재해 주세요. 약간 이런 식의 이제 포지셔닝을 좀 하고 있다라고 생각을 하고요. 네, 저희가 늘상 이제 미팅을 다닐 때마다 드루이드는 뭐 AI 관련해서 뭐 없어요라는 질문을 지난 2년간 많이 받았던 것 같은데 클릭하우스 클라우드는 자연어지리를 받을 수 있는 쿼리 콘솔 자체가 이미 제공이 되고 있고 그 다음에 클릭하우스 클라이언트라고 이제 신기능이긴 한데 저는 한번 봤기 때문에 클릭하우스 클라이언트라고 하는 이 클라이언트 프로그램이 깔려 있으면은 오픈AI나 엔트로픽 API 키를 넣고서 이제 MCP 형태로 이제 클릭하우스를 활용할 수 있는 그런 것도 갖고 있습니다. We're going to be showing the kind of MCP demo later.
Oh yeah, I can show that.
네. Later.
So, but now just the demos for federated queries. So in this case, we have got data that lives in S3. And actually, I mean, I could also show this as a live demo, but pre-recorded is always easier. So you see, as I just say, select star from S3, I give the URL, I give the format, in this case CSV with names, so it has the headers. And now it takes a few seconds, and there's my data. So it's that easy to run a federated query. Same also now connecting to ClickHouse Cloud via the client. By the way, the client and server is all one binary, so you don't have like a dozen different processes. You've got just one binary that you can use for everything. And that is the federated query. Now, the other thing is, why is it now running the same stuff?
Yeah.
Wait, I need to stop this. So, now I think it does the same thing now, but slightly differently. No, okay. Right. Now, what I'm doing now is I'm natively ingesting data. This is an insert as select, and here you can see I have a number of options that define the behavior. So I have parallel distributed insert select, which automatically fans out the insert select to many nodes. I have a few other things that govern exactly how it is, for instance, how it tolerates errors, how it handles the format. And then in the end it ran the query. It ran the query so quick that I didn't even have time to point it out. So it took 0.01 seconds querying the same data in the native format. Now, how to get data in with ClickPipes. This is only in ClickHouse Cloud. In this case here, I'm connecting to a S3 bucket with ClickPipes. So it's just a few clicks, and it will pick up the data that is in that ClickPipes, in that S3 bucket. I can set up continuous ingestion, which means that as soon as any new files show up in that bucket, they will automatically be ingested. And it will also automatically suggest the schema here. And then I can set a few options regarding roles. And then I'm already done. This is the configuration of setting up things in the cloud. So now it's setting up the ClickPipe, loading the data, and there it's already working. I get automatic monitoring. And by the way, another thing that I like about ClickHouse is ClickHouse has built-in monitoring. It has a metrics exporter, and it logs everything to system tables. So if you enable it, which of course is recommended, you have a query log that has one entry per query, and there's a so-called text log, which gives you detailed logs about every step of the query, resource usage and such. So, querying data. This is the SQL console in the cloud. And now I'm querying the data of an internal table, and this is the 0.01 seconds. You can also run an aggregation query, which takes slightly longer, but not much. So this is a group by query over the same data. And then built into the console, you can also visualize it. Although you can, of course, also set up tools like Superset or Metabase or Tableau or many others on top of ClickHouse. This is the demo of the AI Copilot. So just give me the 5 what stays on record. It generates the SQL for me. I get to review it, I get to run it. And Well, it takes a moment, but now we are just reading 16 billion rows, right? There you go. So, to summarize, this is what we looked at. We looked at data warehouses. Data warehouses are ready to use. They speak standard SQL. It's a mature technology. It's been around in one form or the other for the last 25, 30 years. But you get vendor lock-in, you get high cost, you have limitation regarding the latency and regarding the concurrency. You've got data lakes, which give you open access, client agnostic, open storage formats, but they're still evolving. Question is, what is the best format, but also you run into performance limitations and also concurrency limitations. By the way, also Databricks, I heard, is fast as long as you don't run too many concurrent queries, right?
Fast if you have unlimited budget.
Well, oh yeah, if you have unlimited budget, so there you are again. Then you've got analytical databases that are fast at a comparatively inexpensive price point, but mostly they would be considered part of the solution, because most organizations would want to combine analytical databases with data lakes in order to be compatible, and also because, well, you would maybe, oh well, nowadays you might actually want to run your entire data warehouse in ClickHouse. Why not? Because we have been really good at star model schemas and this kind of stuff now. So if you want to migrate, look at the workloads that give you the most value in migrating, understand why they are expensive, migrate interactive workloads to analytical databases, migrate data that you don't need that often, that are just, large data sets, to the open data lake, and this does make your life better.
좀 더 범용적인 데이터 레이크에서 가장 여전히 많이 활용되고 있거나 많이 활용하려고 하는 게 이제 데이터브릭스 플러스 이제 스파크라고 한다 그러면 확실히 이제 빠르고 좀만 익숙하다 그러면 굉장히 유연하게 무엇이든 할 수 있지만 그 QPS라고 하죠. 동시 쿼리만큼은 어쨌든 그 비용을 좀 계속 리니어하게 먹는 부분들이 이슈가 있는 거는 심심찮게 저도 전에 듣는 이야기들이 많이 있고, 그러다 보니까 이런 뭔가 좀 더 데이터베이스의